Hi everyone and welcome back to my channel. Today we are going to learn how to make procedural braids in geometry nodes. Let's get started. I am in Blender version 3.2.1 and the idea is this. We want to create a braid. I don't know if you've ever seen making of braid on a girl, but the movement of each group of hair is similar to an infinite symbol shape. So we need to mix two main shapes. One is a group of line, a straight line with a whip effect, and mix this movement with the final shape we want, so the infinite symbol shape. To do this, I searched on internet some formulas or equation to express the infinity symbol in a graph, y and x axis, and this is the result. We have a scale. In this case we have the time, okay, the time it makes the animation, and with the scale we want the x and y graph. We have to make this formula in the geometry nodes. We have to create a single line. We can press N, go to item, select these vertices, z to 0 and y 0, x to 12 meters. Now s on the z-axis 0 and s to the y-axis 0 to have a straight line. Okay, now tab to exit from the editing mode, go upper in a plus general geometry nodes. This is our line. Click new to create a new geometry nodes. Now we have to create the first of two shape we want to mix, okay, with the animation. First of all, we create the equation add divide. I will go faster for this particular part. 2 divide by subtract 3 divide subtract 3 and cosine of multiply 2 and a value. This is our timing animation. Okay, so the point on the graph changes because this value. Next we will see it in a better way. I select all these nodes, Ctrl G, we can drag this value out and this value out, Ctrl X, tab, and this is the scale, a variable. Now create the x and y part of the equation. We start with x, so we have to multiply by the cosine of what? Of the timing value here. Don't care if you don't understand exactly the equation. I leave in the description a link of the reference page where I picked this formula. Now this is the x value. We have to create the y, so we have to multiply this by 2 and create a sign, multiply by a new scale with the timing on it, and this multiply is divide by 2. We can drag this, select all these nodes, Ctrl G, and now we can export the x and y information and go to group. This is the x information and the y information. The start is the offset on the equation of a value. Tap to exit from this and we have the infinity equation. We can Ctrl X this value. Now to make sure to have a great curve manipulation, we have to resample the curve. I remember you to use the set handle type, the set spline type, not to poly but using the Bezier curve, and the set handle type, and this is my curve. Increase the counts. We can drag these to the input of geometry nodes and count and set the name resolution. Save your project. Now we want all these points one position of the equation of the infinity symbol, and we want to animate these following this shape. So we have to set position of our curve, leaving the x-axis as is, and manipulate only the y and the z, because the x is in this direction. We want the point move with these two axes. So in the z-axis and y-axis, but not in the x. So we have to combine xyz, leaving the x, and use the x and y of our infinity equation as the y and the z axis. So if I link this position, we have all points moved. If I increase this offset, you can see all the points follows the equation offsetting. If I press 7, you can see the equation is very basic. So if I set the 0, we have 1. Do you remember the annotation? We have 1 and minus 1. Okay, we have now 1 here. If I increase this offset, we have minus 1 here, exactly where in the pi value we have minus 1, and in 2 multiplied pi we have another 1 value in this direction, and so on. It's a periodic formula. So select all these points, Ctrl J to create a frame, F2, and rename in initial position on line, okay, G, and this is the first step. The second step is to scale these not from 1 to 1 as the scale of our equation, but in scale and out scale, so the future shape of movement of animation would be more realistic. So we have to scale this position here in the out part of this line, okay, the end of the braid. We want an initial large equation, here a small equation, and while animating we want the scale goes from this large scaling to 0, because the braids will become smaller. It's easy. We can use a map range. We can duplicate with a Shift D the group input to export other variables that we can use after. We need to separate XYZ and combine XYZ because the X now needs to remain the same. Okay, we want to manipulate only the Y and Z value. So we have to multiply the Y and the Z for a value that depends from the duration of the animation and the scale we want, and we can set the output on the new Y and X axis. We have this map range. We can use the magical value of a factor that goes from 0 to 1 to have a scale of the line with these increasing. So we can use the spline parameter. We can use the factor as a value from 0 to 1 and have a scale in and scale out value. We can multiply the Y and X axis by this value. Can rename scale in and scale out from 0 and scale in from 0. Now you can see that in the 0 animation, okay, in the 0 frame, we have an offset of 0 on the equation. Okay, so I have to view this environment with the 7 key to see from the top view the result. If I increase the scaling, I have this behavior, and if I increase the output scale, I have the correct scaling. If I increase the offset, you can see that I have the points follow the equation, but with an initial scale and an out scale. So this is not very realistic. The line is not smooth, so we have to smooth this line to have a whip effect, and to do this we have to add a delay with this offset. So I'll show you how make these nodes more readable. We can select all and Ctrl J, F2, scale from in and out values. Okay, we have the scale. Now we want to create the whip effect, okay, the whip delay of this shape. So to do this, we have to manipulate this offset to add a little delay between all the points, okay, from this first point to the last. And this will create an optical illusion of a whip effect. So we can use a spline parameter. If I use the factor, I have this little offset. But how can I see this in an animation? I have to play with the time information, so we can add with a shift control right button, drag these to add the seconds animation to the factor, and if I play the animation we have this movement. This is the opposite movement. We want this point goes first these points. To do this we have to add a math operation that multiplies the factor by -1 to see this point before this point. So we can see with 7 that from the initial position we have 0 multiplied by -1 equal 0, add by 0 seconds, so the offset is 0, but the scaling is 690. But if I enter 1, we have the initial origin value. So if I increase this, I have an entire round of the equation when I have the division from the frames by this frame rate equal to 2 multiply pi as described before. So I increase this to 30, I add a little split here and choose timeline, so we can see at 0 I have 1, in 30 frame I have this value, but if I want to 30, so after 1 second, 1 round, and we will need this next, I have to normalize this complete round in this interval of time. Now I have scale 1 and I added this part of the layout to better see the timeline. So we have these, okay, we have an entire round after these frames, but to normalize this value I want to have 1 round after the duration of the entire animation. I need to set the entire animation for making the entire braid. So I can duplicate the group input, I have to divide the seconds by a duration, an entire duration, to have a normalized value from 0 to 1. 0 in the start of the animation, 1 to the end of animation I want. So I can set this to divide by a value that is my duration from 0. Now if I link this to the add offset, we can see a similar animation, but I want to normalize this movement in the complete second of this 30 fps. To do this, we see that at the start of the animation we have 1, okay, here, so in the infinity symbol we have this point, okay, of the graph, and then if I move this, we are here, and now if I go here, we have a complete round. So set the duration of 1 second. Okay, with 1 second I have in the first frame this point on the graph. If I increase this and go from the entire round, maybe here, we've done the entire round of the infinity equation. We want to shrink this interval in 1 second, in only 1 second, to better manipulate the animation with mixing between this shape and the final shape of the infinity positions on our braid. To do this, I just have to add a math here to multiply this division and multiply to shrink this value or increase the frequency of the animation on this equation by a factor to multiply pi described before. So now if I go to 1 frame, we have the initial position of the equation. If I go after 1 second, I have another initial round on my equation. This is perfect. We can adjust this operation, select all these nodes, Ctrl J, F2, whip effect on the line. Now we have a duration of the animation, but we could need a speed of the animation. So let's add a speed or a multiply value here by a value, external value, that we want to call speed from 0, okay, and in this case we can have 1 speed, so we have this round in these 30 frames, okay, or I want 2 rounds in the same 30 frames. So if I go in one frame, I have the initial value. After 15 frame, I have the first round, and here I have the second round, and so on. Now I hide the rotation, I set the speed to 1, duration, the speed 5 seconds, and we have this smooth animation of one group of hair. Save the project. Now we can start to make the final shape. So I move this here. The final shape, what is the duplication of this initial position online. So I duplicate this. Instead of assign this position, we can use a mix RGB to have this initial position and the final position, that is now here. I set the factor to 0 to have this position. This factor will be guided by a formula that we will see next. This is our curve. If I increase the offset, I have this. Now we want to offset each point in a different position of the infinity equation to have the final result of braid done. This is the final position, infinity shape. Okay, I can use as before the spline parameter. If I use this factor, we have this, but it sucks. It value too small to see the correct offsetting of each point. We have to multiply by a value or use a map range or similar method. We can add a multiply. So if I increase this multiply, we have these. We can see the offset of the point on our equation. So I have to play with the multiply value to a correct number to let us mixing the shape of the line described before with this new shape while animation. We have to let meet them in some frame. So we can set the same information here, okay, to have a round. So if I set this to 1, this is the result, but 7. You can see if I increase this is the first round. This is the first round from this point of view. So this is naturally 2 multiplied by pi. So if I set this to multiplied by, I have 1 round from the entire line. I want to respect the same frequency that we have here for the line. To do this, I have to duplicate the group input and multiply this value by the speed we want. And if we for a moment duplicate the set position and join together this geometry, we can see this particular factor. So we can use the final position here and the initial position here. So you can see both of these curve. So the final braid shape and the initial whip effect line, the line with the whip effect, and we need to scale this curve from a value of scaling, initial scaling, to 0 at the end of the animation. So to have this, we have to separate XYZ, create a combined XYZ. Now, as mentioned before, for this curve, we have to apply this a similar method here. So we need to maintain the X as is and manipulate the Y and the Z value. So if I press 1 and increase the speed, and for a moment I link all this information, I increase a little bit the speed, you can see more round on this curve. I press 1 and we want to add a math operation of multiply for this node and this node, okay, a value from a map range with a result to multiply with these two values, and we can use the spline parameter. We can use the factor to have from 0 and 1 what the scale in and the scale out of our geometry of our system. So I can duplicate the group input, Alt P to separate the group input from previous layout frame, go here and have a value of a scale in and scale out. But this is not correct because this scale out let us to have the initial whip animation of the straight line, but we need an independent scale out for this final shape. So we have to link the final scaling, okay, this final scaling, the static final scaling, with another value. So we can call this scale out no anim, and now I can set 0, for example. Now this is the more cryptic part of this animation. You can see that if I animate this animation, we have braid in a static position, and the line with the whip effect has always the same out scale, and we don't want that. We want to scale these from this value of scaling to 0 at the end of the animation, because the braids goes to this scale out no anim value. To do this, I tried some method, but the right method is this. You can imagine with the press 1, I increase a little bit the scale, the initial scale. You can see, because we are mixing this shape with this shape, we want to have the points of this shape jumping from a point to the next, follow the position of the final shape of the infinity formula. You can see this in the animation, in the final animation you saw. So to do this, if I increase the animation, you can see I have this point always on this formula until the animation goes over an interval of time. I want to synchronize this point to be able to mix the position of the points of this shape to this shape. The points need to be always synchronized while the animation, okay, from the start to the end of the animation. To do this, it's simple. So we can select all these nodes, Ctrl J to scale infinity equation to 0. To do this, we have to manipulate this zone, the scale. I turn off for a moment the whip effect to have the straight line. I scale this from 3 to 7. Press 1 to see the difference of the position of the straight line and the final position of the braid. And what I want to have cross point between this shape and this shape linearly while the entire animation. So we want this point goes to 0, okay, here. At the same time, we want to have this point go down in the same linearly way to always have the cross value between the two shapes. We have this line. Good. During the animation, we want this line goes down to let each point cross the correct value on the final shape. You can't perfectly see this result with this shape of the curve, but in 3D space you can see it. So to do this, we have to add a math operation to subtract some value to our linearly curve. But what? We have to use a new math range. We want to subtract nothing in the start of the animation, 0, and the scale out itself at the final frame of the entire animation. So we want to subtract the entire value at the end of the animation. The end animation means that we need to add the time information and use the seconds as value from 0 to the duration of the entire animation. So the interval, the entire animation stays in these seconds of duration. From 0 to 1 is this, the interval. So we can use this as a subtract value. We can see now that if I link the whip effect but without the vector delay, so we can mute for a moment with the Ctrl Alt right button drag. This is a link muted. I can show you that while the animation from the start to the end, you see that this point is very close to the position of our infinity equation for the entire animation. So if I move the frame, you can see the point is still close to the final shape. If I continue to move this, you can see the point is here, and now the scale is smaller and the position is still close to the final shape, and so on. If I go here and go here and go here and so on until the entire animation. The entire animation is 5 multiplied by the 30 FPS, so 150 frames. So we have here the final cross position between the two shapes. Now If I unmute Ctrl Alt right button, and this is the same result but with the whip effect. If I press 7, you can see the scale of the point is still close to the animation between the first shape, okay, and the final shape. You can see here is the new point, it goes here and so on linearly to mix the position from one to another shape. The position is not perfectly aligned because we have a delay, a whip effect, but in this case it will not give us a bad result in the end of the animation. So in 150 frames, the end of the animation, we have the cross point to the last point of each shape we want to mix. Now that we have this environment, so position, scaling, and whip effect, here we need to mix the shape from this shape to this shape. To do this, I delete this and this. We set position, we have this, but we want to mix with this final shape. So to do this, I press Ctrl X to delete this node. We want to manipulate this vector. How manipulate this vector? We have two methods you can use. One, we can use formula called arctangent. So this is the formula. We can have this shape and we can shift in this direction we want. So for us this will be the 0 vector and this will be the 1 vector. Or you can use a particular map range to have the same result but without having a long tail here. So you can multiply this equation with a height number to have this jump to mix the two shapes, and I will show you both of them. So I hide the annotation, select the tool, save your project, and we know that the arctangent formula gives us a value of pi divided by 2 with high values, okay, in the x-axis, and minus pi divided by 2 with small values in the x-axis. So if I add a math operation with arctangent, I use a map range to see the result. I can use these to show you the difference. I can move a little bit this set position and use a combine XYZ, a separate XYZ, the original position to show you the behavior of this formula, X in the same way, Y in the same way, X in the same way, and set the position. Okay, this is the original position. So we want to see the arctangent effect that we want to use as a factor in this mix node between the two shapes. So we have to use this as the Z value. So if I increase this value, I have 1. If I increase this value, we have 0. But to see a better result of this arctangent, we can use the factor, spline parameter, factor multiplied by an height number to see the result in the arctangent value. We can see this if I increase this, and we don't want to clamp the value. I want to see a smooth result, not a linear result. And we can see if I increase or decrease the mean and max value, we can adjust this number together. I can set this -2 and this 2, for example. So you can see that we never have a negative number. So to have a negative number, we have to subtract a value to the factor to have a better range of value with positive and negative number. So I can use an add value. I can add a negative value to shift the number of my equation, multiply by a value to have described before a curve more or less smooth between the highest value or the smallest value of the formula, calculate the arctangent and use it with these two and max, min and max value from to have this behavior. These two numbers have to be the same but with the minus for the from min, -1.5 and 1.5, and this add value is the offset that let us to have the transition from one value to the other value from 0 to 1 in a smoother way. If I press 1, you can see the effect. So we can see if I link this color to position, we want one value for the start start of the animation and 0 to the end of the animation. We need to start with 1, so we can use a map range, because to have 1 we need a result a 1. I can shift a little bit this to see the result, link the vector to the position. I can create a node and move this here to have a space. We have to use a map range, so we can add the group input, another group input, the same group input with the time information, seconds used as the value. For the entire duration I want a linear transition from the range of seconds from min to the entire duration, so 0 to 1. This is the interval. We don't want to have values over this interval of this node. We can just play with this value, so we can use this subtract, and we can see if I increase the timing we have the shifting to the left, so we can set the max to -1 to have this transition, because in the first frame we have seconds 0 from min 0, output 0, add 0 factor. We are here at the start of the curve, okay, 0 factor equals 0 multiplied by this number is 0, arctangent, because we are in the exact midpoint of the two values of the range. We have 0 here, so the 0 is in the midpoint of this interval, so we have 0.5 and we have 0.5 here. If I move here to the midpoint of the entire animation, because the animation is 5 seconds, so here the animation ends, we have 0.5 here in this point, and in the final animation we have 0.5 here. This is not perfect for our animation, but this does its job, so we can use this as the factor. We can hide the annotation and use this value as the factor, and use this color as the position. So if I play the animation, you can see the transition points goes from one shape to another. We have a little delay from one shape to another, and to make this better with this transition, we want to delay a little bit this whip effect to better align these two shapes. To do this, I can simply go here in the final position infinity shape and add a little offset here to move the entire points of the final shape, not from the start point, but from the start adding a little value. So the initial shape remains as is, and the final shapes will change a little bit. So I can use this, I can use an add value, and if I increase or decrease a little bit, you can see the delay added. So I can just add a little bit of delay, a little bit, so this can be the result. You can see the transition is too smooth, so we have to increase the value of our arctangent here to make the effect more aggressive. We can use this for now, and this is one of two methods. I'll show you a second method, Ctrl J to create the shape layout of this, F2 mixing factor using arctangent, and now we can use another way. So I will link for a moment this vector to the position to see the second way to mix this value, so it's more clear instead of using the arctangent, because you have to use a very high number here to avoid the tail of the smoothness while the mixing. We can use the spline parameter, the factor, multiply by a higher value. This will be the smooth parameter of our transition, and we can use this with a map range, not in the input value, but I will show you this. We can use the multiply the value from min, the multiply the value, add by a little value, use it for the max value, and get the final value we want, 0 and 1, for our transition and mixing between the shapes. So now if I link this to the z-axis and I increase this value, you can see this behavior. So press 1 to better see the result. I go to 0 value to show the difference. We have 0 factor multiplied by this equals 0. So for the start of the curve, we have 0 and 1 here for the max. We have 0 value in the output, we will have 0. So now I have 1. This means that I have the max value of input and we have a value of 1 at the output. If I increase the value to 5, we have a smooth value from 0 and 5 of all the point. I have to increase the resolution to better see this value, but there is a problem. If I increase too much the resolution, the smoothness shrinked too much. So I have to add some value here to see the result, and you can see a linear transition between this value. If I increase this value, you can see this behavior, and the difference between this method and the arctangent is that before this point and after this point, in the arctangent we don't get the final number of the map range, because the arctangent is not a linear equation. But in this method we always have these two values because of this clamp switch. So all these points are 1 as an output, and these points always have 0 as an output. So we can play with this value to increase or decrease the smoothness. Okay, but we want to animate this value for the entire duration of our animation. We can set this to smooth to have a better result of the transition, and we can use the group input and use the same method described before in the other sections of the group nodes system, using a duplication of this map range using linear, get the time information to have the seconds as the value in an interval between 0 and the maximum duration of the animation, and have with the output what? 0 for the mean and the maximum value we choose for the multiply node for the factor. So in this case we have this behavior in animation. If I go here and link the result to the value, we have this transition. So it ends when to the end of the transition. Here we have 0 value here. It's perfect, but we have a problem. We have a correct 0 value here, so I can set 1 and 0 to have the opposite result. But at the end of a transition, I don't want 1 here, but I want 0 here. To do this, I have one more step. I can simply set for this max value of this map range, not the maximum value I set to have the smooth I want, but this add the same value used here for the max. So if I duplicate this and copy and paste this value and use this here, and duplicate this add and insert here between these two nodes and use the same value, we have a correct result. So I have the transition and we have 0 at the final position. So this is a shifting of the max value used in this map range, and then as a value used in this node, letting us to have a value that could be equal to the max value of a from socket. So this value multiplied by maximum factor 1, so equal to this value, adding this number. This is the max socket value we want here. And here we want to go to the same value in the end of the animation. So now if I link these to the correct socket, we can delete these nodes and we can select all these nodes, Ctrl J, F2, renaming mixing factor using map ranges. We can use this method or this method, you want one or the other, but you have to pay attention that there is a little difference between two techniques. So with the arctangent you have to multiply by a higher value here to have correct transition and avoid a scaling after the mixing between shape. Okay, this is a good result. If I use this technique, you could have to use a properly offset between two shape using the here to have the same result. So keep in mind this aspect. I will use this arctangent method for this tutorial. We can hold this here to have one line. Now we have the animation of one braid. We have to make a curve. So let's add a curve to mesh with a circle curve, but we have to set the radius. So we can set the radius. I can adjust this, but I want to manipulate the radius from a scale, a large scale here, and a small scale to the end point of our curve. So I can use spline parameter, use the factor, multiply the factor by a value that you want. We can use the group input to have radius and group. We can use this as a radius scale in. No, I want to use a map range with a scale in and scale out, radius scale out. So I can use this multiply value here, okay, and use this as the radius. So I can decrease to 0 the scale out and use 1 to my radius in. And instead, using this multiply value, I can use a curve float to better manipulate this value. We can set a value here, like so, and use this factor as an external parameter. So the factor is or not is used in this particular shape. So if I increase this value, I can increase the speed, so I have more and more rounds. I can scale in a little bit this and scale the radius a little bit. Speed is too much, I like it. We can use the factor as we want, and this is the setting of the radius of the curve. So we can select this, Ctrl J to set radius. Now we can create the profile curve and create the UV map described with my previous tutorial, a capture attribute either for this curve, and use the spline parameter, so the float value of the factor, and use these to export the UV map. So I have to create a combiner node to export the value and use this value as an x-axis of the UV map, this as the y, the z remains the same. Remember to set 1 this radius, because this is a multiply factor of the previous scale we set in this set curve radius. Remember that we can assign to this the UV map. Okay, this is the geometry. We can select this, Ctrl J, F2, UV map creation. And now that we have this, we have to create 3 group of hair. So to create 3 group of hair, we have to group the entire graph. So I don't suggest you to select all and press Ctrl G, because we have duplication of this group input. So we have to move these and assign the value before the grouping. Trust me, perfect. We have all these link done. Now we absolutely have to create this node. Select A, not this group input. Ctrl G, tab to have only one node. This is here and this is here. Okay, we have the resolution, scale in, scale out, the duration, the speed, the scale out no anim value, the radius scale in, the radius scale out, and the factor. Tab to exit from the group node. We can delete all this group. Now this is our group hair. Now we have to create 3 separated group of hair so I have to create another 2 instances of these. You can select with Alt and right button, drag one node to another. You can set the curve, and you can, in this fast way, select these 2 nodes and press F to link all the other fields. The same for this instance. These, select these 2 nodes, F, 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 F. Now we have to join these hair in only one group, so we have to press Shift, Ctrl, drag to create the join, Alt, right button and drag to create these. We can export the UV map of each braid, because we will use these on the shader editor, so we can set these as the first UV map, these for the second, and these for the third. We can set UV map 1, UV map 2, UV map 3, and remember to assign to all the output value a name. For example, curve param 1, curve param 2, and curve param 3. Now, in this moment, we have 3 group of hair overlapped to themselves. So we want to offset the entire equation, okay, the entire position of all the points for both of the initial line with whip effect and for the final infinity shape. So I have to enter in this node. I can add a new factor, a new value called hair offset, and use this to offset either these 2 shapes, position of the infinity shape and the initial position on the line, with the same value. I can use these to add a offset value for my infinity equation, so all the points will start to offset to a static number of offsetting. The same here, add, duplicate, Alt P, G, and click to insert this node in this frame and not this frame. Invert these, and we have to link the new input value here for this offset. Drag G to move here, and link these for the same effect here. Sorry, not here, but here. Now I will reuse the group input in a fast way, so to better understand the entire layout. Okay, perfect. This is the initial result we have. Now we have this new hair offset added here for the final position of the infinity shape, and the same offset here for the initial position on the line. So either the shapes will move their static initial position. So tab to exit from this. We can use a value of 0 offset for this factor. We can use this as 0 value from min to value tab. If I increase this value, you can see the entire offsetting of this braid. So I can use a value 0. I can use this for multiply by 2, for example. We can try use this as 1, so 1 value multiplied by 2 is 2. Use it for the second branch, and this for the third branch. 7 to go to the top view. Shift Z to see better the overlapping value. Go to the entire end of the animation to see all these offsetting, and play with this value to have a balanced from one curve to the same curve but next round here. So we can set 2, I think. Shift Z to see the result. We can decrease the radius scale in a little bit. We see that in this zone we have the radius that decrease, so I can increase this radius, but I have this problem here, so we have to have a little scale for the final intersection, but we have holes here. So to fix this behavior, we have to manipulate the x value, okay, the x position of each point, here in the scale from in and out values of the line, and here the infinity equation. So to do this, we have to multiply this value and multiply this value of the x to shrink this value with a number. I move a little bit this geometry section to make space for our new nodes, and we can simply add the spline parameter and use the factor. We can use the group input to have a better result through an external parameter. We can use this factor through a plot curve graph. We can set an important value of this curve factor and use it with a map range where the 0 starts here and 1 is at the end of each curves. So we want to use these as the multiply value here and here, because we want each lines follow the same behavior. We can do this, I can do this. We have the factor passing through this float curve, and we want to limit what? We want zero effect at the start of the points of each two curves. So to have a zero effect, we want to maintain the same x source value of this input. So I have to multiply this value by 1 to have the same value at the output. So we want in the start point 1 coefficient, and at the end of each curve I want to have a value that I can export to my group. So I can rename it in the shrink length. It's obvious I have to press tab to exit from this and link the new parameter outside. Okay, here, link these here and also here. Press tab to enter in the group node. So now if I decrease the length, we have the effect. So I also want this factor outside. So if I decrease the strength, I want this factor to be applied with or without this curve, okay, float curve, to better manipulate the distance and the shape of my braid. So I can drag this factor, rename this as the length fall off, tab, and link this new value outside our geometry nodes, and link the same value here and here, tab to enter, and this is our Ctrl J F2 fall off scale of x-axis. So we can use these as we want, and you can play with this parameter as you want. Now we need material, so we can go here in the group input and add a material 1 plus material 2 and material 3. We can use this where we have to assign the material to the end of our 3 curves. Okay, so we can set material. We need to assign all 3 material to set the ID material in a correct way to each of this group of hair, because the set material index doesn't work if you not set all the material the geometry has to have. So I have to assign all my 3 material. I can use the group input to assign this material here, this here, and this here, and export my material index to decide what material the geometry has to have on each group of hair. So I can press tab to exit from this node, move a little bit here, this value, link the new material socket to the main group input of my geometry nodes. We know that we want to assign the first material, so the 0 index of material for the first branch, the 1 index, so the second material, to the second branch and second index, so the third material to the third branch. I can click, shift click, FFF, click, shift click, FFF to link the three material, but now the index is different, okay, for each branch. Now we have to go in a shading editor. We have to create three material, so I can use these. I can import an attribute, so we have the common material for each branch, so I can use a noise texture, for example, use the color here, shift control click, and you see nothing because we have to apply a name in this socket called parameter 1. Okay, is one of the three value here. We have to add three material. Okay, so three material. For now they are the same, but we will have a different attribute, so we have to select these, Ctrl G. This is the common part of our three material. We have to input the vector. Okay, we want to use in the noise texture, so tab to exit. This is the common node material used for each of our three materials. First is material 1, the second is similar, so I can drag this vector here, and now I can make these different. This is the material 2, and I have to set curve material 2, and for the material 3 we have to set the attribute here as 3. Now in the geometry nodes we have to assign material 2 and material 3 in this way. Press tab to enter here. You don't see anything. Why? Because I have a wrong name on this attribute. Tab to exit from this common node material. I have to set the correct name of this UV map here. Set this param1 and here for the material 2 param2 and param3 param3. Now I see the UV map on my noise texture, so you can manipulate the vector as you want. You can increase or decrease the scale of the direction in the x-axis, so the direction of the curve. You can mix RGB with this color and a color ramp with some value like red and blue, using multiply factor using this color, and use this factor to a gradient factor based by the UV vector, and this is the result. From 0 to 1 you have multiplied this noise texture with this color ramp. So I suggest you to use these without moving the original points of the curve in the z-axis or other position. And if you want to have a more sophisticated shape of this final result, you can just duplicate these, shift D and click, and this is the new line. Hide the original, go to object, convert to mesh. This is now a mesh, so if I enter tab we have lots of vertices. Tab to exit from the edit mode, go to modifier, add modifier curve, and if I add a simple Bezier curve as to scale up a little bit, we can select these, use the curve as an object to get the correct follow direction, and if you press G and X you can move on the x-axis of the curve your braid. And if I manipulate with the tab, if I manipulate these 2 points of the new Bezier curve, S to scale a little bit, S to scale a little bit, I can select both of them, S, and I can do these things. I can increase the resolution, I can rotate these, I can rotate these, I can scale, I can use the tilting of my points and the shape remains stable, and so on. Thank you guys for watching this tutorial. I hope you like it. You can download this project for free on my Gumroad page in the link in the description. If you want to leave a comment, I would appreciate it. Check a like and see you in the next video. Bye!